So today we're going to continue talking about hypothesis testing. Last class we talked about what the null hypothesis is and the alternative. And we also talked about the two types of errors that you can make while hypothesis testing. Because remember, we're just making hypotheses and then we're testing it, but there is room for error when you do that. So we're going to talk next about a level of significance. We call a level of significance the Greek letter alpha. It's kind of like making a little fish, but without filling in the tail or without making that last line for the tail. That's alpha. Yeah, kind of like an A, just more, yeah. So alpha is going to do with a type 1 error. Type 1 error is rejecting the null when it's true. It says, by setting the level of significance at a small value, you're saying that you want the probability of rejecting a true null hypothesis to be small. So the smaller the alpha that's used in a problem, the less you're going to make, or the less possibility of making a type 1 error. And for our purposes, when we do levels of significance, the ones that we are going to see are alpha equals 0.1, alpha equals 0.05, and alpha equals 0.01. Those are the only alphas that we're going to be using in this course. Now there is something called a beta, but that deals with type 2 error, and we're not going to do beta or type 2 errors in this class. So beta is a little bit advanced for what we're going to learn in this class. So again, there is a type 2 error and beta associated with that, but we're not going to be doing that in this class. So if you go on to statistics in college, they might talk about a beta level of significance, but again, it's a little advanced for this class, so we won't be doing it. All right, so level of significance is either going to be 0.1, 0.05, or 0.01. The smaller the alpha, the less chance you have of making that type 1 error. So the best alpha to use is a 0.01. That reduces your chances of making an error. But again, 0.1 and 0.05 are also acceptable levels of significance. All right, so in a statistical test, the first thing you want to do is state both the null hypothesis and the alternative hypothesis. Then you want to determine the level of significance. And again, that's either going to be alpha equals 0.1, alpha equals 0.05, or alpha equals 0.01. Next step, it says a random sample is taken from the population and sample statistics are calculated. So you take a sample and then you calculate the test statistic. Now the test statistic is determined by which population parameter you're trying to find information on. If you're trying to find information on the population mean, your test statistic would be X bar. If you're interested in the population standard deviation, you would use sample standard deviation. If it's population variance, you would use variance for the sample, which is S squared. And finally, if it's population proportion, you would find the test statistic of P hat. So I wanted to remind you, because I had some people earlier today that forgot about some of these symbols. They didn't know S stood for sample standard deviation. They thought it just stood for sample size. So I wanted to remind you, a test statistic is either going to be X bar, S squared, or P hat. It's going to be one of those 4 things. Says the statistic that is compared with the parameter and the null hypothesis is again called the test statistic. And these just literally say what I've written out here in chart form. So 1, state the null hypothesis and alternative. Step 2, find the level of significance that's usually stated in the problem. Step 3, take your sample and calculate your test statistic. Step 4, calculate a p-value or a probability value. It says the probability, if the null hypothesis is true, of obtaining a sample statistic with a value as extreme or more extreme than the one determined from the sample data. And it says it depends on the nature of the test. We'll talk about different types of tests we can do, but just know that a p-value is a probability of finding the null value outside of what your alpha is. I want to note, guys, on 6.2, we will be doing actual calculations for this. So when we actually do calculations, it's going to be a lot easier for you guys to understand p-values and alpha. We're going to be drawing them out so you can see, where's the test statistic compared to where the actual probability. So again, when we start calculating these will make a little bit more sense. I know right now, these are just definitions, but it'll make a lot more sense when we start doing calculations with them. All right. All right, there's 3 types of tests we'll be doing in hypothesis testing. These tests are going to be dependent on the alternative. So 3 types of tests are left-tailed, right-tailed, and two-tailed. The type of test depends on the region of the sampling distribution that favors a rejection of the null. If it favors a rejection of the null, then it's talking about the alternative. This region is indicated by the alternative hypothesis. So again, when you're asked to decide which type of test, look at your alternative hypothesis. That will determine whether it's left-tailed, right-tailed, or two-tailed. All right, a left-tailed test, again, it's dependent on your alternative. Use the left-tailed test when it's the parameter less than something. Less than is to the left, so whenever your alternative is less than, you're going to use a left-tailed test. Go to the next slide, slide 21. Again, we're looking at the alternative to determine the type of test. Whenever it's the parameter greater than, it's going to be a right-tailed test. Final type of test, the two-tailed. What do you guys think the alternative will look like on a two-tailed test?
Would be in the middle.
So we have a right, it's going to be, well, not in the middle, but the outside.
Yeah.
We have a less than, we have a greater than, what's missing? Right, and for this case, since it's alternative, if it's not, since it's alternative, it's going to be not equal to. So whenever the alternative is not equal to, it's going to be a two-tailed test. Now keep in mind, there is a z-score associated with the alpha, and there's going to be areas to the left and to the right. So P is twice the area. So if you calculate the area to the left of a z-score, note that when you find your p-value, you're going to double it because there's 2 of those areas. There's 1 on each side. So with the two-tailed test, the area always has to be doubled because there's 2 of them. Again, we're not doing actual calculations today. We'll be doing those on Wednesday, but you'll see when we do the actual calculations on Wednesday, we'll be doubling the area for that. All right, let's do an example, and I meant to erase that. All right, so it says identify the nature of a test. For each claim, state the null and the alternative. Then determine whether the hypothesis test is a left-handed, left-tailed, right-tailed, or two-tailed. My head hurts so bad. Sketch a normal sampling distribution and shade the area for the p-value. A school publicizes that the proportions of its students who are involved in at least one extracurricular activity is 61%. And what do you guys think I crossed out involved in at least one extracurricular activity? Yeah, the at least might make you think that you use that in your inequality, right? But take a look at it, the wording. What population parameter are we talking about in this problem? Proportion. And proportions are given in percentages or decimals, right? So the reason I crossed that out is because the only thing we're interested in is the actual percentage, which is 61%. So and that's why I crossed out all the other stuff, because it could make you think that, because it says in at least, it could make you think that you're talking about greater than or equal to, but we're just talking about the proportion. We don't care how many extracurricular activities they're involved in. We just care about the proportion. Does that make sense? Okay, so I wanted to mention that. All right, so our parameter we just identified was P. Let's do our alternative and our null. All right, is, what type of inequality or equality is? Equal. So should I put that as the null or the alternative? The null, right? Equal to, so your equality statement goes with the null and the inequality goes with the alternative. All right, well, the equals or the is our claim. So I'm going to label that as claim. Final step, we need to identify which type of test. Does the null or the alternative decide what type of test? Alternative, right? So always when you're doing this, use your alternative to determine the test. Not equal to, is that going to be left-tailed, right-tailed, or two-tailed? Two-tailed, good. All right, questions on that first example? All right, let's do another one so we can practice this.
I'm still confused with like, like the why we're not taking like the one extra curricular activity, like why we're not looking at it.
We're not looking at that because it's just talking about the proportion, and a proportion is either a percentage or decimal.
Oh, no. You know when it says at least the little alligator sign, that's how we were taught. Yeah, we're not doing that. Okay, so
Just right, just for that one, because a proportion is only a percentage.
okay, so when we say proportion,
Right. So if it's talking about at least or less than,
so if it says proportion, it's always going to be equal to or not equal to.
Well, it could have said is it involved in at least one extracurricular activity is greater than 61%.
Oh.
So it's just whatever is right in front of the percentage, and the percentage is what determines. So I'm glad you asked that. Thank you for asking that. All right, let's do another one so we can practice this. A car dealership announces that the mean, what parameter are we dealing with? Mean, good. So here's the null and the alternative. We're dealing with mean. All right, the mean time for an oil change is at least 15 minutes. All right, what is at least? What symbol? Right. So greater than or equal to is the null or the alternative? The null. If it had said greater than, it would have been in the alternative, but because it was at least, it means it could be exactly 15 minutes as well. So our claim is there, our alternative is less than 15 minutes. All right. We use our alternative to decide what type of test. Based on the alternative, what type of test are we talking about? Less than is, right, left-tailed. So always less than is left-tailed, greater than is right-tailed. Right. Left is less. And that's the alternative, not the null, guys. Always look at the alternative to decide the type of test, not the null. All right, I think we're good on that. Do you guys need to see a third one, or you feel good about it? Sure, absolutely. All right, a company that advertises the mean All right, I see that, and I'm immediately writing the parameter. All right, the company advertises that the mean life of its furnaces is less than 18 years. What symbol is less than? Right, just the little alligator, no line under it. So should it be the null or the alternative? Alternative, good. U is less than 18 years. And if that's the alternative, then our null is going to be greater than or equal to 18. And I identify that this alternative is our claim. All right. This one is also a less than. That's funny that they did both less thans. So what type of test is this one going to be? Left. Right. Interesting. Okay, I'm surprised they did both, but that's okay. All right, now guys, a note about tonight or tomorrow's assignment. You guys are going to have a classwork assignment based on this. For those online, you're going to do the assignment based on this. And what you're going to notice, just like last time's homework, is that it's going to be very repetitive, but it's repetitive to get it into your head. So I know I've done it. I know this is kind of repetitive, but again, it's to help you to understand these concepts. So the more you do it, the more you're like, oh, okay, I get this. So go ahead and fill in this chart. We are going to be deciding whether to reject or fail to reject. Notice we never say accept, we just say reject or fail to reject. And that's going to mean something about our claim. But it's going to mean different things based on if our claim is the null or our claim is the alternative. Notice the wording. When we reject the null, if the claim is our null, it says there is enough evidence to support the alternative. If we reject the null and the claim is the alternative, we say there is enough evidence to support the claim. When we fail to reject the null and the claim is the null, we say there's not enough evidence to support the alternative. Finally, if we fail to reject the null and the claim is the alternative, there is not enough evidence to support the claim. So when you do your assignment on this, which for those in person is, well, actually, I think for everyone it's tomorrow, use this chart when writing what the decision will be, because it's going to make a difference. You're going to see in your homework, look at the chart when you write these. All right, let's do an example. Let's use the chart to help us on this. It says, you perform a hypothesis test for the following claim. How should you interpret your decision if you reject the null? If you fail to reject the null? Now notice, guys, the null is the claim. A school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. We've seen this problem already. We already did it. Our null and our alternative. P equals 0.61 and P does not equal 0.61. We already did that before. We talked through it. And now we need to decide what it means. So let's look back. Now keep in mind that our null is the claim. So if we go to the chart, the claim is the null. You guys with me? Okay, we're just going to look at that column when we write it down. So first we need to do reject the null. It says there is enough evidence to support the alternative. And then we're going to tell what the alternative is. That the proportion of students involved in at least one extracurricular activity, I'm not going to write that down, is not equal to 0.61. All right, let's do the second one, failing to reject the null. Again, go back to the table. Use that same column. It says fail to reject null. There is not enough evidence to support the alternative. That the proportion of students involved in at least one extracurricular activity is not equal to 0.61. So again, guys, when you do this assignment tomorrow, keep this chart open and use the chart. And it's going to tell you, you're going to either decide or it's going to tell you which one's the claim. If the null is the claim, then look at this first column. If the alternative is the claim, then look at the second column and use that exact language when writing it, and then just relate it to the problem. Does that make sense?
Can you go back to the fail to reject real quick?
Yeah.
That's basically the same statement, except one says not.
Yeah. Yeah. And notice the other set of statements is different. So the other statement, yeah. So when oh, that's funny, not written down. Notice on the second set of statements, when the claim is the alternative, it says there is enough evidence to support the claim, or there is not enough evidence to support the claim. So just notice the difference between the two. And use that chart while doing that part of the homework. Okay, we already did that. That's the statement that we wrote. So go on to slide number 29. Okay, so the steps of alternative testing, we started talking about them, but let's finish. Step 1, state the null on the alternative. Step 2, specify the level of significance. Alpha equals either 0.1, 0.05, or 0.01. And generally, they'll tell you in the problem. Step 3, determine the standardized sampling distribution and sketch its graph. So that's where you take your sample, you standardize your sample, and you sketch your graph. And we'll probably be kind of skipping that step. Step 4, calculate the test statistic and its corresponding standardized test statistic and add it to your sketch. So we'll be skipping step 3 and really doing that in step 4. Step 5, find your p-value. I'll be showing that to you guys in 6.2. Step 6, use the following decision rule. Is the p-value less than or equal to the level of significance? So is p less than or equal to alpha? If it is, reject the null. If it's not, fail to reject the null. And finally, step 7, Write a statement to interpret the decision in the context of the claim. That's the chart we just looked at. So you use your chart and write that statement. All right, that's it, guys. And again, I will say that this lesson really comes together in 6.2. We actually start using these steps for hypothesis testing.